So this is going to be a short, I have a feeling, review or tutorial. And so questions from quiz 1, love to. I think there's going to be a chart like quiz 1 on the test. So you're wondering about this question here? Those 3 there? Great stuff. So what I'm going to do, oh, by the way, you guys can write this down if you want, or you don't need to. I can print this up for you when we're done, and then I can go really fast and not waste time while you're writing stuff down, and then you can look at it again later when you're rewatching the video. Isn't that clever? So there is going to be a chart, something like this, on your test, and I'm going to make up a different question right now. Hopefully I don't make up the same questions as are on your test, but who knows, I just might. So I'm going to say, you know what, Dunk, O. I'm going to say atomic number 19. I'm going to say helium. I'm going to say how many protons? How about 18? I'm going to say how many electrons? How about 12? And how many protons here? How about 37? I hope this works. And you have a periodic table in front of you somewhere? Here, borrow. Oh, you got it? Okay. What color is the periodic table that I've given you, Riley? Pink. Why is it pink? If it's colored, what does that mean? You can bring it to the test. I will not make you memorize the periodic table, although I showed you a video of a 3-year-old who had the song memorized. So for Pete's sakes, I'm just disappointed in everyone. Okay. So you're telling me, Mateo, that you're okay with this? The name and the symbol. I mean, that's almost free marks, I hope, by now, right? And, by the way, these 2 are always the same. Do you know the atomic number? Because the atomic number is defined by how many protons are in the nucleus. In other words, so atomic number 19, hey, I know that's a 19. 18 protons, I know that's 18 atomic number 18. 37 protons, I know that's atomic number 37. And if I know this or this, I know what element it is, right? So atomic number 19, element number 19, potassium. And atomic number 18, argon. And atomic number 37, rubidium, which is Rb. If you know the number of electrons and it's not an ion, then these are the same. Now, if it is an ion, they won't be the same unless it's a noble gas. Say what? Which one are the noble gases? Oh, I thought Mateo was pointing to the right one. Far right. Why are they so special? Because they have full valence shells, which means they won't react because they don't want to lose or gain electrons. And again, I think I said 50 years ago we would have said they can't react. But actually a guy at UBC managed to force one of them, I think xenon, to react. So now we say they almost totally don't react. They don't form stuff. All right. So what you're wondering about, I think you said, are these 3. But I really think what you're really wondering about,
yeah.
Okay? So oxygen is the first one that I made up. Find it. Oxygen, missing a periodic table, Mr. Dueck. Let's get a periodic table as well. That would be clever of me. Periodic table with polyatomic ions on the back. So here's oxygen, okay? What row is it in? Not column. What row is it in? Second. As a number, row number. I'm going to ask you the same question. What period is it in? It's the same question. Yes. What row is it in? What period is it in? How many electron shells does it have? That's the same question. 2. Those are all different ways of asking the same question. How far down tells you its period, and don't forget to count the first one, Kiana. Second one, so it's in row 2, you got oxygen right here. It's in row 2, it's in period 2, it has 2 electron shells. First one is full, second one not quite.
Wait, so you can like tell by is electron shells or whatever they're called?
Is
by the rows?
the row, how many far down?
Oh, okay.
So let's pick another one. Element 21, find element 21.
Scan.
Scandium. What period is it in?
4.
You know how many electron shells it has? 4. And the inner 3 are full, and the outer one, and this goes to your next question, has, look up, 1, 2, it's got 3 valence electrons. It has 3.
So you just count from the side.
From the left. So you ready? Look up. Let's do oxygen, which is the question that I made up here. Count with me.
1, 2, 3, 4, 5, 6.
Oxygen has 6 valence electrons. Oh, how many electron shells? What period number was oxygen? How many electron shells? Same, different way of saying. That's why it's in period 2.
How do you tell, like, on the periodic table if it's an ion or an atom?
We're going to get to there in a second. To be honest, from the periodic table, you can't. I have to tell you in the question somehow. But the periodic table allows you, if you know it's an ion or if you know it's an atom, to figure out how many electrons it has. Okay, that's a good question. We'll come to that in a bit. Make sure I don't forget. What family number is oxygen? Family number is these ones in black. So oxygen is part of family number 16, which probably has a name, but we don't care about it. What are the 3 families that I'm making you guys not memorize, because it's on the table, but you need to know? Sorry, 4 families. The alkali metals, very reactive. Those are the ones that blew up when you dropped them in water. Remember the video I showed? Alkaline earth metals, honestly, we're not going to talk that much about them, but they're on your periodic table, so I mentioned it. Halogens, these ones are very, very reactive. And then the noble gases, non-reactive. Okay? Keep going. Let's do another one. So, but you're okay with number of neutrons and number of electrons? So oxygen, how many oxygen, atomic number. What's oxygen's atomic number? How many protons?
8.
How many neutrons? You have to do some math.
8.
Oh, 16 take away 8, right? You okay with that?
I don't remember this.
You need to for tomorrow, so that's okay. We're practicing. So you remember? Neutrons is mass minus protons. Why does that work? Because electrons weigh nothing. That's a fib. They weigh almost nothing, but essentially they weigh nothing. So if it has a mass of 16 and 8 of the masses are protons, the rest must be neutrons. If, look up, phosphorus or sulfur has a mass, well, let's go phosphorus, has a mass of 31. See it, Kiana? And it's got 15 protons, the rest must be neutrons. 31 take away 15. The only issue is you do have to round off. So here, 24.3, I'd use 24. Here, 35.5, I'd round that to 36. It's going to be 36, take away 17. Chlorine has 19 neutrons. Okay? We can do that because essentially the electrons have no mass. So let's fill that in. How many neutrons? 8. How many electrons? Same as the number of protons if it's not an ion. How do you know whether it's an ion? The question will tell you. And since this question didn't in fact, this was before you guys knew about ions, we're assuming you have a neutral atom. What do I mean by a neutral atom? How many positives? How many negatives? What's positive 8 plus negative 8? In your head. That's why it's neutral.
So is atomic number and protons the same thing?
Always. In fact, the atomic number is defined by how many protons there are.
And then neutrons and electrons.
Got to do math. Neutrons, you got to do math.
And they're the same.
No. Neutrons, you got to do math.
Yeah.
Electrons, if it's an atom, will be the same as proton because it's neutral. If it's an ion, we'll talk about that. Let's do another one. Potassium. Find it on your periodic table. Right here. Okay? Right? How many protons? 19. See where we get that from? You find it, Kiana? And if not, you can look up. Right there. Okay? How many protons?
19.
What's its atomic number? Same question. How many electrons if it's neutral? Same question.
19.
19. That's all different ways of asking the same thing.
How do you know if it's neutral?
The question has to tell you, okay? You can't tell from the periodic table. So in other words, I'll give you an example of one where it's clearly not neutral. But here on this quiz, you didn't know that they couldn't be neutral yet, so I didn't bother telling you on this quiz. But once I introduced ions to you, I'll show you how I tell you. So hold that. That's also works with Riley's question. Yeah?
So if they're neutral, you don't do like 39 minus 19.
That's to find neutrons.
Oh,
I'm just doing electrons. So you ready? Look up. We're going to do a bunch really, really fast. Just watch. We're not going to write this down. Niobium, how many protons? 41. How many electrons when it's neutral? 41. Silver, how many protons? How many electrons when it's neutral? 47. How many neutrons? Whatever 108 take away 47 is, which is why I said you can feel free to bring a cheap calculator tomorrow, unless you can go 108 take away 47 in your head. I can. 61. Nice. Okay, so it can be done. But on a test, I usually bring a calculator just because I don't want to make a mistake. Okay?
And that would equal to what?
What would equal the what? There was too many pronouns in there. I need some more nouns.
When you take away
Look up. This, take away that, is neutrons.
Oh.
So you ready? Let's try a really, really big one. Osmium. What's its mass, Kiana?
I can't see it. 190.
How many protons? Too slow. How many protons? Just read.
76.
Yes. How many neutrons? Do the math. It's going to be 190, take away 76. Okay? How many electrons? Too slow.
70.
Yes, yes, yes. Okay? And that, I can't, that part, those three, you do have to memorize. Sorry. But it's not as much memorize as recognize, because they're on here. So I can't say you have to commit it. You have to just know how you can find each of these from the numbers that you're given. So let's keep going with the chart now for a bit. Potassium, oh, how many neutrons does potassium have? So potassium has a mass of 39, take away 19. I can do that one in my head. 20, right? So 20 neutrons. How many electrons? Right now, 19, because you didn't know about ions on quiz 1. And I'll show you how you know it's an ion later.
Wait, if it's not neutral?
I'll show you how that works later. Don't worry about that. Don't worry about that. Ooh, valence electrons. First of all, how many shells does potassium have? How many electron shells? How many shells does it have? 4. How many electrons, if you were drawing the Bohr model, how many electrons would you draw in the first shell? Look up, look up, look up. Then, how many electrons would you draw in the next shell? 8. Then, how many would you draw in the next shell? 8. And now, how many would you draw in the valence shell?
18. Or what?
How many would you draw in the valence shell? Just
1? Yeah, 1.
why 1? Look where it is, right? Look up now, watch. If you're drawing it, it has 2 in its innermost shell, then it's got 8 electrons, then it's got 8 more electrons, and in the valence shell, 1 more electron.
But I thought it was neutral, so then I thought you do 30 on it. I meant 20 on the board.
No, that's for neutrons. We're talking
Oh.
valence electrons is how many electrons in the outermost shell. It's got 1 extra. How many electrons does calcium have in its outermost shell? 2. How many electrons does yttrium have in its outermost shell? Look up, look up, look up. 3. Now, I'm not going to ask you how many electrons cadmium has, because it's too much counting and it goes kind of haywire here, okay? I'm going to ask you in this top section and maybe these guys close to the edge where it's easier to count. Also because right here, the periodic table splits, and there should really be another 20 elements in the middle, but it wouldn't fit on one page, so we have to move it down. So let's go back to our chart. How many valence electrons for potassium? 1. How many electron shells? Give me a second here. Pause the video. So, how many electron shells? Potassium. See it? How many electron shells does it have? That's how many valence electrons. How many shells does it have?
4.
4. What period is it in?
4.
4. It's the same question, right? The reason it's in row 4, the reason it's in period 4 is it has 4 electron shells. First 3 are full, and then 1 more in its valence shell. So we can say how many electron shells? 4, period 4. Family, that's the vertical. What family is it in? And family 1 has a special name. It's an alkali metal, which means it's fun to play with if you're ever allowed to. When I was in high school, we did get to play with sodium, and we got to drop it in water, and it would explode. But I'm sure somewhere, a kid was dumb and that wrecked it for everybody across North America, and now we don't play with it anymore. But it was cool for a while. This says He. Which one is He? Helium. Okay, so its symbol is He. What's its atomic number? 2. How many protons? Same question. 2. How many I'm going to skip neutrons. How many electrons? Same question. 2. How many neutrons? Do math. So let's go look.
2.
Oh, also 2? Oh, yeah. 4, take away 2. I just don't want you to think, oh, protons and neutrons are the same. No, they are near the beginning because the atoms are simpler. The elements are simpler. So 2. Ready? What's the next question? How many valence electrons? Look up. Oh, sorry. 1. Don't count hydrogen twice. Don't count hydrogen twice. 2. That's why that innermost shell only holds 2. Okay? How many electron shells from the periodic table? Yes, just 1. First row. Remember, shells is rows. And I haven't thought of a good, stupid way to remember that shells and rows go together. But shells, periods, and rows are that's the same thing. I'll try and come up with something stupid, but I haven't yet. So how many electron shells? 1, because it's in the first row. What's its period? Period 1. What's its family? Family number 18, and those have a special name. Family 18 is part of the snooty noble gases. Okay? Does that help answer your question okay, Mateo?
Yeah.
Kiana, you have a question. Or did you?
No, I was just,
You got to go? Or you just packing up? Did you have, what were you wondering about?
is this the test?
Yeah, okay. So you know what? Now that I've done this, let's talk, since you guys have both asked about ions, let's talk about ions, and then I'll finish up doing some Bohr diagram examples, okay? So, do I have quiz 2 here? Here, quiz 2. Oh, it's in Word, Mr. Dueck. Because I'm going to give you a chart, kind of, sort of, something, kind of, sort of, something like this, okay? So let's copy this chart, and again, I'll just change the values. In fact, I think that's what I did for your test as well. Yeah? You have to go to another class? Okay, go, and then if you're done early, come back and see if we're still here. Okay, kiddo? I need to shrink this down a wee bit. Ready, Kiana? Read to me what this says. Which is which element? Magnesium. You know what? I'm going to say, instead of magnesium, I'm going to do calcium. Where's calcium? How is calcium related to magnesium in terms of its location? Row is horizontal. I got to be fussy. Not in the same row, in the same column, or word that begins with letter F. Same family. Okay? That means a lot of these numbers might be the same. First of all, calcium atomic number?
20. Oh,
Yeah, 20? Right? How many protons? 20. Those ones, I can't call that a no-brainer because I've had to teach you that. You need to memorize that. But that's as close as we're going to get in this unit to a no-brainer in that, okay, 20, 20. Now answering your question. You asked, how do I know if it's an atom or an ion? Okay? If it's an atom, it has the same number of protons and electrons. So if it has 18 protons, it has 18 electrons. If it has 5 protons, it has. Now, if it's an atom and you have 5 positives and 5 negatives, what's its charge? What's 5 positive? Huh?
0.
So, ready? That's an atom, that's an atom. These 3 are ions because their charge is not 0.
So
Now, we'll talk more than that, but for starters, you asked, how can I tell if something is an ion? If it has a charge. Now, how do I show that? In the chart I've said, or if I write it, that's an atom, that's an ion. I put the charge. By the way, that's not just a plus, that's a plus. What number is sitting there invisibly?
1.
1. We just, for some reason, on the periodic table, they're lazy with the ones, much like in math.
So
Yes,
that ion charge column, are you gonna do like the same thing on the test?
maybe. Okay.
Or do we have to like find out what the ion?
Well, to be honest, I think I can do a bit of both. I think I can give you in fact, you know what? Remind me, I'll add one more question at the end. Let's keep going with this. So what's its ion charge? 0. That means it's an atom, and it also has 20 electrons. Let's do one that's an ion, but let's not do atomic number 8. I say to you, let's do atomic number 15. Now, stop. Atomic number 15 can't have an ion charge of 2 minus. Find atomic number 15 and tell me what its ion charge must be. Okay. So I would have to have done that too. Which element? F. Oh no, just P, right?
Isn't calcium 2+, not 0?
When it's an ion, not when it's an atom. I'm telling you that calcium in that first line is an atom and is equal, okay? It's not stable. By the way, what's also the case is this particular atom is not stable because it wants a full valence shell, and right now it has 2 electrons in its valence shell, and it really wants to get rid of them. It's going to be reactive. Anyways, let's keep going with this row first. Atom or ion? Ion. Okay? How many protons? Close to a no-brainer. 15. How many electrons? That's going to change. Now I need to think. Ready? Can you read that to me, Mateo? That means it's picked up 3 minuses. What are minuses? Protons or electrons? Electrons. This is from chapter 1, right? So, Kiana, it has picked up 3 minuses. What are minuses? Electrons. Normally, how many electrons would it have?
16.
No. Electrons. You're doing neutrons. Electrons. 15. I didn't ask anything about neutrons in this question. Neutrons is where you do the math. Do you see neutrons anywhere in my chart?
Oh.
Stop doing math. Don't need to. Ready? So, normally, if it was an atom, how many electrons does phosphorus have? 15. What does this mean? 3 more minuses. What are minuses the same as? Electrons. So how many electrons does it have now?
13 or 18. So just 3 plus protons?
Not 3 plus protons. Protons never change.
No, like protons plus 3.
No. Protons never change. Only electrons change. So, ready? Since you brought it up, let's do 3 plus, and let me pick a different one here. Let's do 21 protons. So if it's 21 protons, what atomic number is it?
21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21. 21
It's an ion. How do I know? Because there's a charge. Okay? Okay. Normally, how many electrons does scandium have? 21. Look at scandium on your periodic table. Find it. Keep your eyes on it. Is it close to the left or close to the right?
Left.
Because it's a metal, it wants to lose electrons. How many electrons does it need to lose to get rid of its valence shell?
Two, three.
Not two or, no, just count.
1, 2, 2.
No,
1, 2, 3.
right? You're overcomplicating this.
No, so like you
Three.
Count, you count.
Three.
Actual, like,
Square, yeah, that's when during the lesson I kept saying, we count. So how many electrons does it want to lose? 3. So now this goes to your question, because protons don't change. But by losing 3 negatives, 3 electrons, it becomes 3 more positive. It's not gaining 3 protons. It becomes 3 positive. So normally it has 21 electrons. You guys just told me that it lost 3.
that has 18.
Yeah. That was so much fun. Let's do another one. Let's suppose you have one that says 2 negative, and it has 10 electrons. Neon, however, you asked a great question. Okay, you said it's neon. Stare at neon, because that's going to be what help us figure out what we are. The problem is, how many protons does neon have?
10.
Okay, what's neon's charge?
0.
So it can't be 2 negative. But in this row, what has a charge of 2 negative, an ion charge of 2 negative? What element must we? You know what? We're talking about an oxygen ion. Is what we're talking about. So let's fill in what we can. I just figured out it's oxygen. Atomic number 8. Oh, and I got the number of protons, 8. Oh, and since it has a charge, ion. I told you I was going to add a column. So you know what? Let's go. Supposing I gave you and I told you that it had, I got to do some quick math here. And it has an ion charge of,
So you're always going to give us the charge?
being careful here, has an ion charge of, I have to if it's an ion for this particular chart. Okay? This is tough. How many electrons? 18. Find element number 18. That's going to be our starting point.
Argon.
Okay? Look at it, stare at it, put your finger at it, whatever you need to do. Now, I need to be 3 more positive than argon. So, right here, you know what? It's scandium again. Because scandium has 21 protons. Normally it has 21 electrons, but how many does it want to lose to become stable?
3.
Which would give it 18. So you can also see the numbers are sort of hidden on there, but I choose to count because I'm better at counting than remembering all this stuff. Now, how else can I tell you it's an ion? If I actually say, that's an atom, that's an ion. Is chlorine a minus? I think it is, yes? In fact, everything in that column, in column 17, in the halogens, in family 17, is a minus, right? Means every one of those just needs to gain how many electrons to become a full valence shell? Just 1. And when they gain 1, they'll have an extra minus. That's the tricky part, Matteo, and I've gone on my rant how Ben Franklin named these backwards. When you gain an electron, everybody wants to add 1. I've gained, shouldn't that be +1? You gained a negative. You're -1. So let's do some Bohr diagrams. Did I hear a bad word out there? I don't know. If I did, I'll go shoot them. You did? Okay, let me go get them, but I gotta pause the video first. So last thing I want to talk about is what are called Bohr diagrams. I'm going to ask you to draw some Bohr diagrams on your test. Oh, by the way, some more basics. You got periodic table? Where are the metals? You need to know this. Where are the metals on the periodic table? You did some coloring. We were supposed to know this. Okay, so I'll bring the periodic table up. Where are the metals? It says on the table. Psst, look up, look up, look up. Where are the metals?
The color blue.
That to the left. Where are the non-metals? To the right. Where are the metalloids, the one that behave a little bit about right along this staircasey thing, which is why that staircase is there. It's saying aluminum is a metal, but silicon is a metalloid. It behaves a little bit like a metal. It behaves a little bit like a non-metal. Metals conduct. Metals can be turned into wires. Metals are generally shiny. Non-metals are not. Yeah?
For metalloids, would it be like anything here, or just like any on this side and this side?
Okay.
Of the thing?
I'm not going to be that uber fussy, but for what it's worth, since you asked, it is where's our periodic table? I think the periodic table is in second right there. Oh, too far. Somewhere in the textbook it's got a lovely picture summary, but I'll be honest, I've never really bothered memorizing it. There's the periodic table. There's the metalloids, but there's a better picture, I seem to recall. Oh, there you go. Hey, there's the metalloids. You know what? It's along the staircase, but not quite. I'm not going to say to you, which of the following are metalloids? What I am going to say on your test is, here's a periodic table that's blank. Put a check mark where the metals are. Put a check mark where the non-metals are. Put a check mark roughly where the metalloids are. Yep. Okay. It's okay.
I'll watch the video.
Yep. And I'll print this up and I'll probably send an email as an attachment. Hopefully by 5. It's got to render for a while. Okay. So, back to tutorial, Mr. Dueck. Bohr diagrams. On your test, I'm going to say something like this. Draw a Bohr diagram of, pick an element somewhere near the first 3 rows, don't go way down.
Silicon.
Thank you.
No problem. How do I know that's not an ion? Riley, how do I know that's not an ion? If it was an ion, what would I have beside it? Little tiny charge. Now, if you look at silicon, by the way, and this is something I don't like, did they put a charge on silicon and on carbon?
No.
No. We're going to pretend the charge is 4 minus, because if you count from the right-hand side, they're both 4 from the right, and they want to gain 4 electrons. Although carbon is also 4 from the left, is it not? Look at carbon. This is why carbon bonds so well with everything. It can lose or it can gain electrons. We're not going to get into why that is, but I know that's why they left the charge off, because they didn't want to say, but you can kind of figure it out by counting from 4. You gave me silicon, I'll draw it. Okay? No, that's okay. Ready? Here's what a Bohr diagram looks like. No, I'm going to print this up for you. You can watch and then you can try drawing it yourself. Right? It's in all honesty, Mateo, it's how you learn best. If you think you'll learn best by drawing with me, then draw with me. If you think you'll learn better by watching, great. First thing we do is the nucleus. And in the nucleus, or below, I don't care which, we say how many protons and neutrons. Silicon, how many protons, how many neutrons?
14
14 what?
protons.
14 P plus, or you could put a little 14P right there.
And then 14 neutrons.
Is it 14 as well? Is it 28? Well, that's nice. 14 N0, or you could put a 14N right there.
Mr. Duke, do you draw down, like, on the Bohr diagram, the neutrons or the protons?
Both.
But
I just did. You're asking the wrong question. Hang on, you're asking the wrong question, so patience. I've told them protons and neutrons. What the Bohr diagram is going to show is what's important, where all the action is, which is not the protons, which is not the neutrons. It's the electrons. So you ready? See silicon? What row is it in? I disagree. It's third row, is it not? Don't forget hydrogen, helium.
Oh, yeah, yeah.
Don't, okay. Row what?
Three.
How many shells does it have? Same question.
Three.
In other words, I know it's going to be 1, 2, 3. How many electrons are going to go in the innermost shell? Top row, how many does it hold? And we pair them together. Why? It has to do with quantum entanglement and spin, and don't worry about it. We pair them together. How many go in the next row? Sorry, in the next shell, which comes from the next row, 8. So I would go 1, 2, 3, 4, pair 5, pair 6, pair 7, pair 8. How many are going to go in the next row? Now we count from the left.
4.
And it goes like this. 1, 2, 3, 4. Okay, there's a Bohr diagram of silicon. What's just to the right of silicon?
Aluminum.
To the right. Phosphorus? What if the question had said, draw a Bohr diagram of phosphorus? Okay, I would change that. So now it's going to be, how many protons does phosphorus have? How many neutrons? 16. How many electrons? First of all, still the same row, so it's still going to be 3 shells, right? And it's still going to have 2, right? It's still going to have 8, right? How many electrons now in the outer, in the valence shell? Count. Pair the 5th one up. You do 4, right? You go north, south, east, west, and then pair, 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 pair. Am I going to ask you to draw bromine that has 17 electrons in its valence? No. No. In fact, the highest I'm probably going to hit maybe is scandium, 21 or 22, because asking you to draw 4 electrons or 3 electrons in the valence shell isn't hideous. But there is a Bohr diagram of phosphorus. What if I was drawing a Bohr diagram? Hey, what's to the right of phosphorus?
sulfur.
Add one more electron, change the protons, change the neutrons. So these are Bohr diagrams. Let's try one more, and then we're going to do an ion. Or do you guys want to try an ion right now?
Right.
Do an ion? Okay. Draw. We'll do 2 ions. We'll do one metal and one non-metal, because they're slightly different. Let's do a metal. How about, blah, 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 blah. Oh, heck. Nah. Sodium. Now, if I just wrote this, that would be not an ion. So I'm going to start out drawing it not an ion, then I'll change it to an ion so you can see how it changes. So I would say, okay, how many protons?
Oh.
How many neutrons? Is he right? Is it 12? And again, you can either tuck them in the nucleus if you can fit them in, but I think on one of your assignments, I gave you one that had it all shaded in. And so you can also, if you want to go, hey, there's the nucleus, and down here you can go 12 protons. No, 11, you said 11, right? 11 protons, 12 neutrons. As long as somewhere I see that, somewhere. What row is it in?
3.
So it's going to have 1, 2, 3, 2, 8,
And then 1 on
and this is what makes it so unstable, because it wants to get rid of, it wants a full valence shell. And to get a full valence shell, how many electrons does it need to lose?
1.
Just 1. Now, losing an electron will make you More positive or more negative?
Positive.
And that's why, if I wanted to, I would say draw Na plus. What would Na plus look like? This whole shell would vanish. It's given that away. But to show that it's an ion, to show that we meant to draw this, because you might say, we've drawn sodium wrong. No, I want to show the marker that I know it's lost an electron, that it's an ion. We put square brackets around the picture, and the ion charge right there. That's our way of saying, I didn't screw up.
What if it has 3 rows when it has 3
It
shells?
used to, but it gave away its outer shell. Great question. Okay? Oh, and it's now positive. By the way, this is how chemicals combine. I'll show you. Let's do another one. Here, we'll go with draw, how about O2 negative? Really, this should be a subscript, so let's do that. Okay? An oxygen ion. How do I know that's an ion and not an atom?
This shows the
And
trend.
now I've answered your question as well. How do I know? Either the question will tell you, or if you see the charge, right? Okay. You know what? I'm going to do the dot for the nucleus again. So there's the nucleus. Oxygen, how many protons? I think 8, right? That one I'm starting to memorize because, you know, I breathe it. And 8.
Do we have to do P plus and N0?
I want you to show me the number of protons and neutrons.
No,
and-
like P and then like.
I'll clue in, but
plus.
you know what? I do that just to reinforce to myself that protons are positive. Why not? Takes one, but I won't take marks off. As long as you clearly show me. In fact, if you wrote the word protons, I'm fine with that. If you wrote out the word neutrons, I'm fine with that. Okay. What row is oxygen in?
2.
So it's got a full inner shell. And then it's got, normally, before it becomes an ion, count from the left. How many valence electrons does it have? So normally it's 1, 2, 3, 4, 5, 6. It wants a full shell. It's not going to lose 6 electrons to get a full shell. What's it going to do instead?
Again.
Now, where do those electrons come from? One came from this sodium, the outer valence shell, and if there was another sodium, let's say right here, it also gave oxygen its electron. In fact, if you're combining sodium and oxygen, it turns out you need 2 sodiums for every 1 oxygen, because oxygen wants 2 electrons, and each of them has 1 to spare. Not only that, this is an ion. Did I say ion? I have to show that I meant to do this on purpose. How do I do that? Square brackets to say I know this is an ion, and the ion charge. Positive or negative?
Positive.
Positive or negative?
Negative.
Turns out, unlike charges, positive and negatives attract each other. And because oxygen is negative and because sodium is positive, they will be attracted, they will chemically bond. It's called an ionic bond. And now we're starting to see, how chemicals get put together. I told you, everything, all the action is where the electrons are. The protons never change because they determine what kind of atom you have, but the electrons can change and they determine how they bond. Is that okay?
Mm-hmm.
So that's for ion. So on your test, I'm going to probably ask you to draw an atom of something, Bohr diagram, and I'm going to ask you to draw an ion of something, Bohr diagram. What else is on your test? Definitely need to know where the metals, the metalloids, and the nonmetals are. Hey, it's on your periodic table mostly. The only thing that's not on your periodic table is the metalloids. Hey, it's along the staircase. I'm not going to ask you to be specific. I'm going to say, show me roughly where it is. You need to, I've tried to explain why certain things are reactive. So why don't the noble gases react? What makes them special?
Because they have the 0.
A 0.
A 0.
That won't get you anything. I need more specific. Why don't they have a charge? I'm looking for 3 words, one of which is the word valence. They have already, here's the 3 words, full valence shells. Look, they can't gain or lose. That's why they're not going to react. That's why they're stable. Why are the alkalis so reactive? Column 1. How many valence electrons do they have? So is it easy for them to get rid of that? Yeah, and they really want to. Okay, drop them in water, they go boom. Hey, why is column 17 so reactive? How many electrons do the halogens need to get a full valence shell? Just one. They'll rip it from you. By the way, don't ever muck around with those. In fact, I showed you guys a video, and I'll be showing it to you again. Fluorine is the only chemical you can't store it in glass. It eats glass. Everything, glass is kind of the chemist's best friend. We store almost everything in glass. Can't with fluorine. Fluorine has to be, it's a special coated plastic polymer. You can store fluorine in there. Pardon me?
I said, does the glass like crack, or does it just like?
I have a video. Remind me sometime, I'll show it to you. I just released today. So there's a great website, a great YouTube channel called the Periodic Table of Videos. It's from a university in Britain. And there's a guy, he does chemistry videos. And so what they did on the weekend was they lowered a light bulb into hydrofluoric, can you hear the fluorine acid, and just let the acid eat away at it. It's actually quite cool. Remind me, I'll show it to you guys sometime, but not today. Unless you want to after this is done. I just can't show it in the video.
If you say where are the noble gases, do you say
Column 18.
column 18? That's it.
By the way, do you have to memorize that? No. Why? Look at the bottom of column 18. What does it say there?
Noble gases.
Okay, right? And this is what I said before Kiana left. You don't have to memorize, but you got to know what's there and how to interpret it. What else might I ask? So certainly you need to know. So these guys here, the metals, gain electrons. How can you tell they gain electrons? Electron, negative or positive?
Negative.
They gain negative. Look at their ion charges. That's why their ion charges are negative. These ones, and Matteo, I'm glad you made that mistake. They don't gain protons. They're not allowed to. But what's another way to become more positive? Lose negatives. Lose electrons. Which also explains why, because all electricity is electrons moving through wires. You can hear the word electron in the word electricity. What are wires made out of? Metal. Why? Because metals want to get rid of electrons. So they'll send the electrons through the wires, no problem. No problem. Okay? You do need to know what all of these mean. Oh, wait a minute. No, you have that on your periodic table, it turns out. Fair enough. But you need to be able to interpret it. Now, the only thing we haven't talked about yet, we will more next chapter, is these ones that have more than one number, like nickel. What's its ion charge?
2 plus 3.
Or 3. It usually forms 2. It usually loses 2 electrons. Sometimes it can lose 3 electrons. Wait a minute, Mr. Yeah, and this is why I've said most of what I'm teaching you is wrong. As soon as you get further down, it turns out the shells twist and overlap and tangle, and so this Bohr model that I'm giving you is totally garbage for anything past element 22. But it helps you understand at least why some atoms are so reactive and some aren't, gaining and losing electrons. Do you have any other questions? And sorry, I didn't get a chance to give you guys a study guide this time. I didn't put one together. Although if I can, you know what? Here's what I'll finish with. I'll pause the video for 1 second. If you want practice from your textbook, if you're looking for some more review, if you go to page 72, can you open your textbook to page 72? There's a chapter review. Here are questions that I like. I like number 3. I like number 3. I like number 3. Number 3 is a nice question. Why would I say that? Oh, they don't know. Okay. Number 4. And again, if you're studying, if you can do these without writing anything, skip them. You know it. So I'm guessing most of you can do number 3 and number 4 pretty easily, I hope. Number 9, 10, 11, absolutely. 13, absolutely. These are questions that I would say you should know because you'll see them some way. or you might need to know them to answer a question on the test that assumes you know this part.
Is there gonna be like multiple choice questions?
Yep, it's going to be about 20 multiple choice and then some fill in the blank and then some written. Oh, and then drawing a couple of word diagrams, which I guess is written. 13 totally. 15. 16. 17. 18. 19 you should be able to handle. 22. 23. 24. Wow. 25. Americium, ruthenium. I know where uranium is. I'd have to look for the other ones. 25 is fair game. 27. Oh, take a look at 28. That's a good multiple choice question. So a good multiple choice question would be, I give you a Bohr diagram, and I say, hey, tell me what element it is. How can you figure it out? First of all, look at number 28. Does it say they're ions or atoms? Atoms, which means the number of electrons is the same as the number of, which means count the electrons and you know the protons, and you know the atomic number, and you know the element. I mean, that was a bunch of dominoes that fall into place there, right? But if you know if it's an atom, you know the electrons, then you know the protons, then you know the atomic number, then you know the element. That's a nice multiple choice question as well, giving you that. To be honest, if you only know the electrons and it's an ion, you need more information because, good question, everything in this column, nitrogen, oxygen, and fluorine, when they become ions, all have 10 electrons because they all have a full valence shell now. Everything in this column here, silicon, phosphorus, sulfur, chlorine, when they become ions, they all have 18. So that wouldn't, the number of electrons when it's an ion doesn't tell you what it came from. Good question. So that gives you some extra practice if you want. Is that okay?
Yeah.
And I gave you guys a candy for showing up. Give me 1 second. I'm going to pause the video.